All right, welcome to Chapter 3, or Module 3, whichever you want to call it. In Module 3, we cover Chapter 3. And in Module 2, we dealt with data types, and we touched on different types of data that we will save for future use, whether it's mathematical or numerical things that we need to do, or if it's text-based. It could be images or objects that we're actually saving beyond just the traditional data types. But for this module, we're going to deal with numbers. And I'm going to dip our feet in this first video, and we're not going to dig deep. And we're going to start off by talking about booleans. Now, booleans are essentially a true-false. Either something is or it is not. It's a yes or a no. Are you alive? Yes or no. There is no in between. I mean, some days we may feel that way, but for the sake of this, these are things that have to be either one case or the other. And what it boils down to, much like the way memory is stored on a computer, it's broken down into the smallest piece of data. It's a 0 or a 1. It's like a little switch. It's either on or it's off. And that's what a Boolean is. Okay. Now, traditionally, we've got two values, true and false. And those are reserved keywords. We touched on that previously. There's some things that you just can't use when it comes to specific words in programming. There's ways we name things to avoid using these reserved words. So the word true and the word false, with the first letter being uppercase, is reserved. If the first letter was a small t, that is different, and that is not reserved. I suggest you not use those words at all to avoid any confusion. Now, that doesn't mean that you couldn't use them in a string, and we'll talk about that in a future module. So for this, we're dealing with Booleans first, and you think true, false, that's not a number. Well, it is. It's something that's being stored as a 0 or a 1 value, true or a false. So beyond that, let's go look and see what do we see next, and that is integers. Now, an integer is a whole number, non-fractional number. So when we say non-fractional, there's nothing after the decimal point other than potentially 0. 10.0. Now we leave the 0 off because there's nothing there. So it's just the 10. So whole numbers, for example, a 5, a 0, 9, 143. Those are integers. 10.5, that is not an integer. That is a fractional number. That is 10 and a half. That's decimal. And in Python, we'll use a floating decimal point or the float data type. I'll talk about that in a little bit. So for now, let's just talk about integers. Now, integers are those whole numbers. I can store them literally, or it could be something that is calculated. Now, any sequence of digits is stored literally in memory as that number. Now, 5, that's a sequence of one number. 5, 0, that's a sequence of two numbers that represents 50. So we will call that a literal integer. It's literally that sequence of numbers interpreted as the value. So when we look at it in our code, we may see, and the example they have is 5, but if that said 5 followed by 0, followed by 1, 501, that's not 501, that's 501. So it's literally what you see there. We'll call that a literal integer. Now, if I store that into a variable, the word literal can get confusing. Literal in this instance does not mean it's static and never changes. It means it's interpreted literally as it's read in. Now, if it was just a 0, that's one number, we'll literally read that in and that means 0. But if we get to 0 followed by another number, we're going to get an error. Now, if 0 is followed by 1, anything between 1 and 9, we're going to get an error. And the reason we'll get an error is because a number that starts with 0 is interpreted as a base. And we'll talk about bases here in a little bit. But for what we're doing now, if it's a number in Python, start with not 0, but anything 1 to 9. So if I said input a number 5, and then I want to divide that by 2, I'm not going to divide it by 0, 2. I'm going to divide it by 2. So avoid that 0 on the front end. Should be fairly straightforward for you. Just understand that if you choose to use a 0 in front for whatever reason, Python will throw you an error because it's interpreting it literally. And 0, 5 is not an actual number that it can interpret. All right. So, talk a little more about it. 1, 2, 3. That's literally 1, 2, 3. A positive or plus 1, 2, 3, it's the same thing, and the plus is implicit. So we don't need to explicitly put that plus symbol in to tell it, oh, that's a positive 1, 2, 3, or 123, literally. On the flip side, if we're looking at it from the negative perspective, everything is implicitly positive unless you define it as a negative. So if you want it to be defined as a negative, and it's like anything else in math, you have to put that dash in front of it or the minus symbol. That will then have it interpreted literally as a negative 123. Okay, it's one of those things that I talked about it previously. Python can be a very implicit language, not as much as it was in version 2.x. In 3.x, it's far more explicit, but there still are implicit things that take place. Much like, if we look up here, 0 before a number is going to be interpreted as a base. Like I said, we'll talk about bases in a little bit. Okay. Another thing to keep in mind, do not put commas in your numbers. It'll do that for us in outputting if we format it properly. All right. Python does not deal with commas or that notation. All right. If we have commas in there, that means we're talking about different pieces of data, and we can see it here in this example. 1, 0, 0, 0, 0, 0, 0 is interpreted as a set of numbers including 1 and a 0 and a 0. Now, we think back, I said anything starting with 0, we can't do things like that. Well, it interpreted that as 0 because there was nothing following it. So it didn't see that as an error. You can use an underscore, but I really don't know why you would use an underscore as a separator. Commas just will format numbers in a way that insert the commas, but that'll be as output formatting or string formatting using a certain function or a certain string function we'll use to format the output. But for storing data, we don't store commas. So beyond that, the operations associated with integers. Standard math operations. Plus is addition, subtraction, multiplication, floating point division. 2 forward slashes is truncating division, meaning you're rounding off. You're I shouldn't say rounding. You're dropping whatever comes after the decimal point. Modulus focuses on, is there a remainder or not? And 2 asterisks is to the power of exponents. So this means 3 to the power of 4. Ends up being 81. 3 asterisk asterisk 2 is 3 squared. Okay, so beyond that, it works fairly straightforward. You'll see I've got a notebook in here for you in module 3. It's COP1000 underscore module 3 IPY notebook. Now in there you can go in and play with it. Know that some of these symbols mean something in LaTeX, and LaTeX is the language of sorts that I have to use to be able to provide text to you in the Jupyter Notebook. These operators are keyword kind of concepts, like the word true we saw before. That means something. Uppercase T, lowercase R-U-E means something to Python. These operators mean something. The asterisk twice means something. The asterisk once means something to Python when it goes to interpret whatever we've written. All right. Same thing in LaTeX. So if you go in to put comments into your notebook, so you're going to have a notebook that you're going to work on in module 4. You need to have comments explaining what you're doing. All right. Comments in Python, we just go in and put the pound symbol and whatever follows it in that line, that's our comment. If you want to include a text box in your notebook, just remember that certain things may appear different. Right. The PEMDAS, or sequence of operation, we'll talk about that in a little bit, but these are just standard mathematical operations. And here they're talking about what I was just explaining. One's division and one is truncated division. Okay, so we'll go ahead, we'll end this, and then we'll come back in the next module, and we'll talk about how literals and variables differ.